Hello, everybody. So today we're talking about multiplying and dividing rational expressions. So the rules for multiplying rational expressions are pretty much the same as those for multiplying regular old fractions. You multiply the numerators and you multiply the denominators, and then you simplify if you can, or you can actually simplify sometimes before you multiply them together. So a over b times c over d is going to equal a times c over b times d. Okay, so here we've got an example. 4x cubed over 3x times negative 6x squared over 10x to the fourth. So I'm going to go ahead and multiply these together. 4 times negative 6 is negative 24. X cubed times x squared is x to the fifth. Okay, 3 times 10 is 30. And x times x to the fourth is x to the fifth. Now I can cancel. Okay, so I know that x to the fifth over x to the fifth just cancels, and you get 1. And 6 will go into 24 4 times. 6 will go into 30 5 times. And so this whole thing reduces to negative 4/5. Okay, pretty easy one. Now I could have canceled to start with if I wanted to. I could have done this. And I actually recommend that you do this, especially on the more complicated problems, because it's just simpler to multiply them that way. So I've got an x here that'll cancel one of those x's up there. So that's x squared. Those two there will cancel 2 of those there. These 2 will cancel these 2 over here. So that's gone. 3 will go in here twice. And 2 will go in there twice, and 2 will go in there 5 times. And you multiply, and you're going to get negative 4 over 5 again. So it doesn't matter which way you do it. Whatever's easiest for you. Okay, let's look at the next one here. Okay, we've got x over 5x squared minus 20x times 4 minus x times 2x squared plus x minus 3. Okay, so here's what I would do on this one. I would definitely simplify these. I'm going to factor all these if I can. So x, okay, I can factor out a 5x here, and that leaves me with an x minus 4 times x minus 4 over here. This will factor, I think, 2x and x. I didn't leave myself enough room, did I? Okay, so I'm going to get x here, and I've got factors of 3. I got to make 1, so I'm going to put the 3 here and a 1 here, and I need a plus 1, so it's going to be minus 2x plus 3x, and that makes negative 3. Okay, so this is factored. Now I can look at this, and I can say, well, let's see, I've got an x here that'll cancel that x, and I got an x minus 4 here that'll cancel that x minus 4. So what am I left with? Well, I've got nothing left on top, which means there's a 1 on top. And on the bottom, I've got 5 times 2x plus 3 times x minus 1. I would probably just leave it like that rather than multiply this all back out again. Couple reasons. One, it tells me when I start doing domain and range, which we haven't really talked about yet, I'm going to be able to find the domain much easier if this is already factored. Okay, I'll just leave it at that because we got domain and range coming up. So yeah, I'm just going to leave it like that, and I'm good to go. Okay, moving right along. 3x over 2x squared minus 9x plus 10 times 2x minus 5. Okay, so the first thing I'm going to do is put this over 1. And I'm also going to factor this here if I can. All right, so I got 2x and I got x. I'm going to go with 5 and 2. Let's see, what does that do? That gives me 10 and 2. Now that makes 8. That's not going to work. I need to make a 9. So how about, is that going to factor? I could go 5 and 2 this way. That gives me, yep, there we go. Okay, so it's going to be minus and minus. So I get negative 4x, negative 5x makes negative 9x, and negative times negative is a positive. So we got that factored. Whoops, not equals 2. Times 2x minus 5 over 1. Okay. Now, I can look at this and I can say, hey, I got 2x minus 5 and a 2x minus 5. That goes away. So now I can multiply this together. I get 3x on top. And I get x minus 2 times 1 on the bottom with just x minus 2. And there we go. Again, I'm going to leave it like that. There's nothing I can do to that anyways, but there we go. We're done. Okay, dividing rational expressions. So you divide these the same way you do regular fractions. So if I've got a over b divided by c over d, that means I'm going to invert this one and multiply. So I'm going to get a over b times d over c, and that's going to be a times d over b times c. So it works exactly the same way, except I got to remember to flip the second one. Okay, which makes this one really pretty easy because 3x over x plus 2 times x plus 2 over x minus 6. Okay, the x plus 2's cancel out. And I'm left with 3x on the top, and I'm left with x minus 6 on the bottom. So I'm done with that one. Okay, sometimes we get these. This is a good reason to put this over 1 because people forget to flip it. So this is going to be, I'm going to go ahead and factor the top one here. This is going to be x minus 2, x plus 2. Can't do anything to the bottom. Times, flip this over, it's 1 over x minus 2. Okay, so then, be a nice green color to go here. That's going to cancel that. And I'm going to end up with x plus 2 over 2x squared. Done. Okay, the boiling point of water is 212 degrees Fahrenheit at sea level. At higher elevations, however, water boils at lower temperatures. A model for the boiling point B of water at x thousand feet is B equals 212 minus 1.85x. So basically what this says is for every 1,000 feet that you go up in altitude, this boiling temperature here drops by 1.85 degrees. The time t in minutes required to boil a medium-sized potato is given by this model. Time equals 40 times 237 minus b over b minus 162. Now the b is coming from here. Okay, so calculate the time t that it would take to boil a potato in Bozeman, Montana, elevation 4,795 feet. Richwood, West Virginia, elevation 2,194 feet, and Milwaukee, Oregon, elevation 37 feet. So I got to do this problem 3 times. So the first thing I would do is Bozeman, I would probably round this to 5,000 because it's dang near there. I'd probably round the West Virginia one down to 2,000. You could put decimals in there, so this would be 4.795 for B, or for X. So we got to start with that, right? So let's start with B. So B for Bozeman is going to be 212 minus 1.85 times 4.795. All right, so I get out my handy-dandy TI-84 plus C Silver Edition graphing calculator, or a reasonable facsimile thereof, and I figure out what this is. So 1.85 times 4.795. This is going to be 212 minus 8.87. We'll just round it to there. Well, I guess we could take it to 1. And then 212 minus 8.871 is going to be 203.129. Okay. Now, we're going to go ahead and plug that in here. So the time, t, is going to be 40 times 237 minus 203.129 all over 203.129 minus 162. Okay, so we're going to do the parentheses first. So this is going to equal 40 times 33.871 divided by 203.129 minus 162. Going to be 41.129. So the top we'll just go ahead and calculate the whole thing. This is going to be T is going to be 32.94. So I'd probably say 33 minutes. Okay, so Bozeman's going to take about 33 minutes. Okay. Now, let's go to Virginia. We got to do this all over again. So let's take all this right here. Let's group that up and shrink it so we got a little bit more room right here. All right, there's Bozeman. Okay, what was the town? Richwood. So Richwood. Okay, we got to calculate B again. So B is going to equal 212 minus 1.85 times, all right, what's the altitude? 2,194, so that's going to be 2.194 all over, whoops, that's it, not over, that's the next one. Okay, so 1.85 minus, or times, oops, 2.194. Okay, that's 4.0589. It's going to come out to be 207.9411. Okay, there's my B. Now I got to figure out what T is. So T is going to be 40 times 237 minus 207.9411 all over 207.9411 minus 162. Okay, time to calculate T, the time now. All right, so 237 minus 207.9411. This is going to be 40 times 29.0589 all over 45.9411. You could probably round this to the nearest hundredths and you're not going to be off. So 40 times 29.0589. Okay, this is going to come out to be 25.3 minutes. Okay, so it takes less time in Richwood than it did in Bozeman. You could really mess with the guys on Iron Chef if you were cooking at altitude. Okay, so I'm going to let you pause the video and do the Milwaukee one and see how long it would take to boil a potato there, and then you can jump back on and see how you did. Okay, first we're going to calculate B. B is going to be 212 minus 1.85 times, what's 37 going to be? Well, that's going to be 0.037 all over, whoops, again, I screwed that up. That's the next equation. Okay, so B what in the world? 1.85 times 0.037. Okay, that's going to be 212 minus 0.06845. All right, so B is going to equal 211.9. We're going to round it to 0.93. Okay, so we've got B. Now we got to calculate T. T is going to equal 40 times 237 minus 211.93 all over 211.93 minus 162. Okay, 237 minus 211.93. T is going to be 40 times 25.07 over 49.93. Now I can go ahead and calculate that. It's going to come out to be 20.08, so basically 28 minutes. Or 20 minutes, sorry. So, a lot shorter of a time in Milwaukee than it would take you in Bozeman, Montana. So hopefully that's what you got. If you just put 20 minutes, I'm really good with that. Okay. There we go. All right, so there's this nice little worksheet for you to work on here. Have fun with that. I will see you guys in class. Have a great evening.